Namaste everyone. In this video, we'll be solving a problem on kinetics, wherein we will have to use D'Alembert's principle to bring the object, which is actually dynamic, into equilibrium, and then we can apply the equations of equilibrium to find stuff. In this particular problem, we have been given two bodies on slant planes. Angles for both the slant planes have been given, and we find here that the angle on this side, on the right side, that is 45 degrees, is much greater than what is the angle here. If you want to find that angle, of course we can use tan inverse of 3 by 4, which gives us 36.87 degrees. Now, not only is the angle greater on the right side plane, but also the weight is more, which means definitely the motion is going to occur at this side, and the motion of the lift block will be happening at the upper side. Now, since they are connected with the same string, acceleration will be same on both the sides. And since here we have been told that the pulley is smooth, the tension that we have on both sides of the string will also be the same. Here I have noted all the given data. It is starting from rest and reaching a final velocity of 3 meters per second. Friction has also been given. We have been told to find the displacement and time. So we will be using the free body diagram method for solving this. Let's take the free body diagram of the first object and put on all the forces that are acting on this. So there is a tension here acting T. The vertical force, that is weight, acting here, that is 200 newtons. There will be a normal reaction acting at the point where there is contact with the surface. So let's call it as R1. And since the object motion is in the upper direction, the friction will be acting opposite to the motion, that is in this direction. And we know the coefficient of friction is 0.2. So this one will be 0.2 times R1. We will have to use the X and Y axis here instead of horizontal and vertical. This being positive X axis and this being Y. The angle that we get here will be same as alpha that we have found. Let's just put alpha. Instead of using this approximated angle, we'll be using this triangle method to find the length of hypotenuse, and we'll apply the sine and cos rules to find alpha. The sine of alpha will be opposite by hypotenuse, so that will be 3 by 5, and cos of alpha will be adjacent by hypotenuse, that is 4 by 5. Let's now go ahead and apply the equations of equilibrium. First we will apply in y direction, then in x direction. So let us take all the components of forces in y direction first. R1 is acting in positive y direction, so it should be positive. A component of 200, that is 200 into cos alpha, this will be acting opposite to y, so it has to be negative. The remaining forces are parallel to x-axis, so they will not have any component in y. So this total has to be equal to 0. R1 is not known. Minus 200 times cos alpha is 4 by 5. So let's use this value to find R1, which we get as 160. Now let's take the components in x direction. P is acting in positive x direction. Then friction is acting opposite to it. And there will be a component of this weight which will act opposite to x. So that also is negative. And the component itself is 200 sine of alpha. Once again, because we forgot actually one particular force which allows us to apply these equations of equilibrium, that is the force of inertia. I've already told that acceleration is acting upwards, so the inertia force will be acting opposite to the acceleration force, and this is where the inertia force will be acting. So when you are taking the x components of all the forces, we will have to consider the inertia force, that is negative. Now let's substitute. Sigma x has to be 0 because we have considered the inertia force. Tension, keep it as it is, minus 0.2 times R1 we found, so let us substitute, minus 200 times sine alpha, which is 3 by 5, minus inertia force. So now inertia force will be mass into acceleration. Mass of this body is 200. Now 200 is a weight actually. So to find mass, divided by g, and then multiplied with the acceleration with which this body is moving. So these are all the x components of forces. So let us find the formula for t. All these values are negative, so let's send them to the other side. Combining these values will give us 152, and this, let us keep it as it is, 200 by g into a. Of course we are taking it to the other side, so it becomes positive. So this is our equation number 1. Next we will take the free body diagram of the second object and put all the forces acting on this. So the weight is acting downwards and its weight is 300 newtons. The force which is acting on this end is tension, that will be same as T. There will be a normal reaction acting at from the surface, let's call it as R2. And now the object itself is moving in downward direction, so the friction acting on this surface will be in upward direction, and that will be 0.2 times R2. And lastly, of course, last time we had forgotten to take the inertia force. Let's take that as well. So inertia force will also act opposite to the acceleration. Acceleration is acting downwards, so inertia force will be acting upwards. Again, we'll have to take the x and y directions. So this being the y direction and here the x direction. This side we will take it as positive, and this side positive for y. The angle that's here is of course 45 degrees. So let's again apply the equations of equilibrium. First we will take up in y direction. Now R2 is acting in positive y direction, and the component of 300 will be acting opposite, that is 300 into cos of 45 degrees. Now the sum of all the vertical components, y components, will be 0, and on the other side we just have this. So R2 can be found as 300 into cos 45, which comes out to be 212.13. So this is in newtons. Next we will have to take all the components in y direction. Sorry, y direction is over. We will have to take next the x components. So now the component of 300 is acting in positive x direction. So let's take that. 300 sine of 45, that will be. Rest all the forces are acting opposite to our positive x. So minus t minus fi and minus 0.2 times r2. Sigma x of course has to be 0 because we have considered the inertia force. This will be coming back to equilibrium, and let us substitute whatever other values we know. So let's keep this as it is, minus tension. So we know the tension formula from our previous equation here. Let us substitute that. Of course there's going to be a bracket here, minus fi. So for fi we'll have to take mass of the second object, that is 300 by g, multiplied with the acceleration, and finally we have minus 0.2 times r2. Now r2 we have found to be 212.13. So let's take all these values. You can see that only a is the unknown over here, and remaining everything is known. So both these quantities become negative. Let's send to the other side. We get 200 by g plus 300 by g into a on the right side, and the values left here, if we do the calculation, if you calculate all the remaining terms on the right side, we get 17.71. So acceleration will be 17.71 times g divided by, because the denominators are same here on the left, we can just add their numerators, that will be 500. So this implies that acceleration is equal to 17.71 into 9.81 divided by 500, which is coming out to be 0.347. So that's our acceleration. Now using this acceleration we'll be able to find both the quantities that we have been asked to find in the question, First, let us go for the tension. We know the formula for tension. Let us substitute the value of acceleration. So that is 152 plus 200 by 9.81 times A, that is 0.347. So that comes out to be, it implies that when you feed it in the calculator, we can see we are getting 159.07. So this, of course, will be in newtons. So this is one of the answers. So next we need to find the displacement. So here we'll have to use the kinematic equation. We know the initial and final velocities, and we also found the acceleration. So we'll have to go for the third equation of motion, that is 2as equals v square minus u square. So yes will be v square minus u square whole divided by 2 times a. So that when you calculate, we are getting 12.97. Now this is displacement, so it's just going to be in meters. So that's our answer. So we have found all the answers that were asked in the question. Hope you have understood this particular problem. That's it for this video. In another video, we'll take up another problem like this. If you get any doubts what's the problem that we have solved, let me know in the comment section. And probably I'll set up a question with random input on Moodle that you will be able to practice when you get access to your Moodle course. Thanks for now, and goodbye till next video.